two webinars from our partners were already done. And now I would like to introduce another speaker, Volodymyr Oliinyk. Good morning, good day, I don't know.
Hello. Hello.
Yes, we are pleased to meet you today at our webinar, and we are expecting something interesting about artificial intelligence. If I'm not mistaken, this is your topic for today.
Yes,
actually, Volodymyr has 15 years of experience in software development and business automation, also at project management and delivery. And also this person is a co-founder of INVOCO, if I'm not mistaken with pronunciation of this company.
Yes,
maybe you will share your experience about this. So now the floor is yours, and I will keep silence.
Yeah, thank you for this presentation. Okay, so let's start. Today I would like to speak about AI, artificial intelligence, and its impact on software development. First of all, as you said, I have a very different experience in the industry, in education, and so on. And finally, last years I was focused on AI, and I'll tell you why. First of all, today we have a huge hype around all those artificial intelligence, language model. I bet all of you have used or at least heard something about ChatGPT. Please write if there is anyone who did not know what it is or haven't tried it yet. And if you ask this person, then go and try it, because these tools will probably change our lives. Of course, it's not something ideal. It's not artificial intelligence in general sense, but I think today I hope I will give you an overview of what AI actually is, what modern applications are, and what the future might be. No one knows, of course. So this year, 2023, is definitely many medias call it revolutionary, because indeed all those new achievements in AI makes it is making it now, and it will make huge changes in life of every one of us and in the industries. Here is a small diagram by Goldman Sachs, and you can see how different industries might be affected by those achievements in AI. Especially we're talking about humans. So can AI replace all the people that are working in all these fields? And especially for us, it is interesting how it will affect software engineering development. You may also saw a lot of maybe videos on YouTube on answering this question: will AI replace software development? Well, the general answer is no, of course. And if you will look at this diagram, you can see the last bar, probably computer and mathematical. I think software development should be somewhere here. So it will not be likely replaced, as you can see, but AI can greatly complement it. let's try to figure out what are we talking about and how AI can help software developers and change the industry as well. First of all, I think it is necessary to make a step back and just ask yourself a question: and what actually is artificial intelligence? Because we are using intelligent systems, tools, we're trying to make machines more intelligent, but what is artificial intelligence? In fact, it's something that is commonly associated with humans. So we can make two different definitions of that. The first one is if some machine or program can behave like a human, I mean, it can mimic some human behavior, then we can call it intelligent. And here is a well-known Turing test, which was proposed, I guess, 80 years ago, something like that. And it is still relevant. And it is one of the most popular definitions of artificial intelligence. So it doesn't matter how the program work inside, what algorithms we're using. The main feature that we expect to see in it is behavior. On the other hand, there is another approach that says that no, stop. Well, if I don't know, a calculator can perform some task that a human can do, it is not intelligent at all. It is just a program, an algorithm. So isn't it better to try to mimic the process of thinking, how a person can reason, how can we make decisions? Maybe it should be some chain of thoughts or something like that. So we should focus on this process. Anyway, these two completely different definitions give us some understanding of what AI is, and it's rather fuzzy term. It's hard to say that some let's say solution is or program application is intelligent and another is not. The edge, there is no sharp edge here. But anyway, it's not about the definitions, but the solutions and applications. And that's what we're doing in AI. And in fact, there may be different levels of intelligence in our applications. First, the lowest level, and in fact, it's the level that is already well used by human society. It's so-called intelligent tools. It's when for example, everyone uses smartphones, and we're using technologies like Face ID, so the device can identify the owner of this smartphone and so on. So we're just solving a small little task, computer vision for this example, but there might be a lot of others. But of course, we want to have more intelligent solution and build so-called intelligent agents. You can see it in the left part of this picture. This is much more complex task, and in fact, we did not have any really intelligent solutions for this until this year. This year brings us new achievements in generative AI, and it may have great perspectives, and so that's why I want to show it to you today. Technically, AI consists of different technologies and areas. The most important today is machine learning, deep learning. I will give more details on the next slides. But I still want to point your attention that there were completely different approaches to create intelligent solutions. For example, there was times, it was 1780s of last centuries, when knowledge-based systems was very popular. You know, probably remember decision systems, expert systems, and so on. When we tried to formulate our knowledge in some concise forms of sentences, of rules maybe, and use maybe some logic to manipulate it. Another important part of AI is all the algorithms for planning, for search, and so on. I suppose many of you knows about these techniques, these algorithms like tree search, graph search, and in fact, this is a powerful tool for solving problems. Yeah, we can, for example, I don't know, make a chess bot, a bot for playing chess, just analyzing all possible solutions. Of course, this is not relevant for real-time applications because of so-called curse of dimensionality, but it on the early stages of artificial intelligence, it was well, it was used, let's say so. Technically, there are lots of fields where AI can be used and is actually used. I will not spend time on it, but computer vision, NLP, content generation, of course, robotics, is very it's an emerging area now. Because we have a lot of algorithms that can power it, and the hardware that can use those software, let's say so, and a lot more. But as I said earlier, the dominant part or technology in artificial intelligence is machine learning. Few words what it is. Let's imagine we are writing program for correcting mistakes in the words. Let's say we switch to characters and make a mistake in the word the. But how can we make a traditional program that can solve this task to correct all our mistakes? Sure, we can. It's not a problem. We can, for example, check all the pairs of each symbols, maybe use some different approaches, but this program will be very complex and it will still not work as good as we want. Much better results can be achieved by using machine learning approach. The idea is that we can gather a data set of such examples, wrong words and correct ones, and feed it to some learning algorithm and make it find how it should work. Yes, so the patterns maybe so it must learn by itself how it should work, and the developer should just make this learning algorithm, and then we can apply it to different tasks without additional modifications. Or of course, in practice there will be, but in general the idea is like that. And this approach showed really great results. As you can see, machine learning has a lot of branches, the most important probably is supervised learning, when we have an example pairs, the input and the output, and we can just show it to our model, and then we can find what our model is actually predicting, compare it to the desired result. If it's not the same, then we should correct the internal weights or maybe some structure to make it fit better. And so this fitting process will make ideally that that such machine learning model will learn to solve our task. So that's the idea. Sure, simple machine learning models was I can give you an example. It can be just a linear predictor. Yeah, so it may be just a vector of some weights, as you can see here, simple program, and you just have an input vector and just find the product between those weights and the input, and that will be your output. But of course, for more complex tasks, it's not that easy, and machine learning started to shine when it became deep. Deep learning, in fact, it's almost the same as neural networks, because it's the main it's the main type of the models we're using. So it has a lot of so-called neurons that are stacked into the layers, and the layers can be very deep. And the idea behind that is that not only we're making this model more nonlinear, more complex, and give more power, let's say, more features to this model, but the idea is also, it's like there are a lot of inspiration from neurobiology. For example, if we're talking about our eye is also it can receive only the most primitive signals, let's say. So it can just react on the light and on some primitive movements. But then this pattern is let's say gathered together, and it becomes more and more complex, as you can see. So this hierarchical pipeline, how we process the data, and it makes much more complex tasks to be possible to solve with this models. So deep learning is the field where it started to shine, let's say so, because after it was invented, neural networks and deep learning architectures in general was implemented in let's say Google for machine translation, and all those face recognitions and other tasks are all using deep neural networks. So it became possible because not only because of the models and the algorithms, but this was one of the three important bricks in this construction. The other two is definitely computational resources, and especially GPUs, TPUs really affect performance and make possible to train really huge models. Today we're going to talk about the most modern architectures, and there are billions and trillions parameters to be learned, and it requires tremendous computational resources. And of course, not only resources, but we need the data. Terabytes and petabytes of data should be processed by those learning algorithms to achieve desired results, let's say so. And the final step that brings us to the day is generative AI. Generative models is probably the last, well, they are the newest one, at least, and are those that made ChatGPT and other large language models possible. The idea is that these models are used to create content, different types of content, and AI really shines with complex and human content, if I can say so. I mean, we humans interact with each other using speech, texts, and of course, visual information. That's why this content, visual, audio, text, are really important. And of course, and so recent achievements made possible creating absolutely realistic photographs of, let's say, given a textual description. You can generate a photo and or maybe some painting. There were cases when AI generated paintings won awards and digital competitions of the artists. And this is a huge problem now. The same for generating maybe some fakes in audio, video content, and so AI is not only giving us good things, but new challenges as well. But the field I want to focus today is generating text generators, and a bit later code generations, because this is really important for software developers, and we'll see. If we're talking about text generation, then the basic model is language model. Language model is definitely nothing but a probability distribution over words in some text corpus. This means that if we will process a large portion of text data, we may find how the words are connected to each other, and solve the task of prediction the next let's say word for simplicity in this in some text sequence. Let it be a sentence. Well, actually, that's exactly what ChatGPT is doing. ChatGPT is just like an example. There are lots of other similar models. So you give it some context, some previous text, and it just generates next words. Well, it's very easy. As you can see, there is a history. You want to predict next element. You have if you have a probability distribution that you will have the conditioned probability of next word, and you can then choose either the maximum probable word, or maybe do some sampling when you choose the word based on its probability, but not in some stochastic manner, let's say so. But well, the language model is actually not enough. It may be good for generating some essays, and that's what it was used for on early stages. And the text looked well, rather good. It might be not perfect. It may imagine something that is not real, and those assets may contain, I don't know, unicorns on the field near your house. But in general, it looked like a story, an essay. But this was a toy, nothing more. The real things began when those models became large. And the motivation behind that is that it's like a small kid that can do very little things, but when it is growing, its abilities is emerging rapidly. So this emerging abilities was noticed in language models when it was increasing in size. By increasing size, we usually mean the quantity of parameters. It's not that simple, of course. The architecture is becoming more complex because we should solve some challenges training these models, in maybe optimizing resources usage for this training, and then using in production. But in general, you can see the picture on the right, and it shows that increasing parameters are making loss functions smaller. This means that the quality of the results is rising. So it is obvious that it makes sense to improve, to increase the size of language models. And below you may see some models and how rapidly they rise. The size of it is rising. Finally, probably the most well-known and recognized language models, GPT models, GPT-4, which is now actually used. There's no exact technical information. It's a commercial model, and it was not published, but it's definitely its size. It has definitely more than 1 trillion parameters, and this is not the cap. We have technical options how to make it even larger. What's behind? How these models are implemented inside? As I said, this is deep learning models, and so some kind of neural networks should be inside. Most commonly used network architecture today is transformer, not only in LLMs for text processing, but for other fields. It's becoming some standard architecture. I will not go into the details about this architecture, but you may see that there are some layers, some processing layers, and the key idea of transformer is so-called attention mechanisms, which points attention between some, let's say, some query and some values that you have. So, for example, in case of machine translation, where there might be different quantity of words in original string and translated, and the order of the words might be different in different languages. You may see that it correctly finds proper mapping between the words and different languages. And that's the idea. If you want details, please go to original paper. Attention is all you need. It's classical. So this architecture really allowed building huge models, and the results was already amazing. But all we were talking about before is generating next word for text sequences that is good for creating essays. But how can we use it in many other tasks, like classification, maybe finding similarity, summarization of text, question answering, and a lot of more that natural language processing have. Technically, we can still use this same model, and when it becomes larger, it gains more abilities to solve much more complex tasks. So technically, we can create our input, we call it prompt, and make it give a special structure to it. So this structured prompt may contain, let's say, I don't know, 4 maybe question answering. Yeah. So we then will make special structure where the first part will contain question, and then there will be some placeholder where the model should append an answer. And in such manner, a lot of tasks can be solved by, at least technically, formulated and tried to be solved by those large language models. But if we use the model trained only on general text corpuses, so just a lot of text, maybe grabbed from the internet, Wikipedia, and so on, it's not enough. Indeed, prompt engineering is important, and now new positions is appearing in the market, like prompt engineer, special person who is good at asking right questions, let's say, so generating this prompts. This is important, but that's not enough. Definitely, the models should be fine-tuned for these instructions. How is it done? Well, first of all, there are 3 stages. This is an example for GPT-3, I guess, but the idea is similar for training other models. So first, we may use supervised learning. This was the one that expect your train data to have examples, example pairs, input and output. So we may create such data set for the instructions we want. If this is question answering, then it can be question and answer pairs, and just fine tune already trained large language model on it. After that, we can even more improve the quality of the results by using the approach called reinforcement learning. What is reinforcement learning? It's another area of artificial intelligence and machine learning, in fact, where we do not give the exact answer but we encourage our model that some actions or replies in case of language model is good and some are bad. Some is better than other. So we're building some reward models and then learning it and then using it to fine-tune this model even more. And this such technique gave us really good, powerful and actual models like GPT-3 and ChatGPT. So this is the basic training methods that were used to create them. Okay, how can we use it? Is there any maybe future for such models, or can it be used some different ways except of just prompting some text and receiving answers by the end users? Of course, and this is a very emergently growing market when we are using those basic or foundational, they're called LLMs, to create a lot of different applications, so-called LLM-powered applications. What's the idea behind that? LLM provides a great basic mechanisms of understanding natural speech converted to text, natural prompts, and so on. But it does not have actual knowledge, maybe corporate access to corporate databases, and well, is limited in many ways. But we can use all those benefits of large language models and empower our other applications by this. And here is an example, a general diagram how it can be made. If you're interested, I can guide you to a framework library called LangChain. It's probably the most known and popular orchestration library. Orchestration means it connects all the components together and provides an option to use different types of LLMs. And just a few words about LLMs. There are large and popular commercial models that can be accessed by APIs and of course are paid for commercial use at least, but there are a lot of open source models. Falcon, probably the most known large open source language models that can be used in your startups and other well, applications. But how can we use it? Well, this orchestration libraries usually provide an access to APIs, to your local or maybe cloud based LLMs, but it's not the only thing that it do. First, it allows you to work with your data, because let's imagine some use case when you're automating some client support service. Of course, you will have a knowledge base of problems that applies to your case, to your business, and so on. And LLM knows nothing about it. what you can do is provide your internal content, textual content as a context to the LLM, and use LLM to query your data and to provide answers based on your data. So this is the top layer of this diagram, contextual data, and it can be in different forms. Ideally, it should be embedded. It means that text data should be converted to some internal representation, which is much smaller and is much more effective. It can be used more effectively than just the text data. Also, another important part of this diagram is different agents, so-called agents, plugins, APIs. What does this mean? It is important, for example, you want to get some most recent information from the internet. Let's say browse some website or get information from Wikipedia. Or maybe you want to make some special mathematical calculations on which modern LLMs are not that great. So these all are external tools that you might use together with the LLMs, and this gives much more abilities to your AI-powered applications. So this is maybe too brief, but description of how you can build new types of applications using those modern generative AI. And this field is developing very rapidly. In fact, LangChain has appeared just at the end of the last year, and now it is used, and a lot of big companies are trying it, at least trying it in their processes. This field of development is really big because I just want to mention some security problems that, let's say, large companies, corporations will not want to send their private data to some public APIs, LLMs, and so on. So LLMs should be moved to the company, and of course they need developers to make it work, to maintain it, to develop, and that's it. So that's why machine learning engineers are becoming well, popular. I will not say very popular, but this position is started to appear in the list of jobs. Let's say so. Well, so as a result, we may expect a new general architecture of generative AI applications. It may look something like that. So there is definitely a place for general foundational LLM models, different types, commercial and open source, and so on, special frameworks, and of course, client applications that are actually normal applications, but powered by LLM and LLM frameworks. And of course, it makes new project routines required for creating such applications. So not only you should create or choose foundational models, but then you should pay attention to prompt engineering, fine-tuning it on your own personal data. Then ideally you should align it with the human feedback. And it's just the first stage. After that, the application integration should be made, and it includes not only optimization but deployment. So so this is another important task where DevOps are involved, and they require special knowledge in machine learning and so on. So it makes a demand for these specialists as well. Okay, so this was a part about developing new types of applications, so-called LLM-powered applications. But if you're just a developer and do not want to work in the field of machine learning and keep writing software on the language that you like and you know, how can you benefit from this modern AI achievements? I think that there are two in fact main points. First is a great educational potential that such AI tools provides us. If you, well, in general, those models will definitely change education greatly, because it makes little sense in just making a student write an essay because he will go and ask ChatGPT to write it for him. But if you are studying, if you are learning some, let's say, if you are a beginner in development, you are learning some frameworks, maybe languages, it may be very helpful to you, because if you're stuck with some problem, you don't know how to find a solution, you may always just ask even publicly available, even ChatGPT, and it will provide you not only the snippets of code, but a good structured description. It might not always be perfect in terms of writing real-world applications, but for the basic things like that you may normally find in the manuals, in documentation, those tools are really great. So for beginners and for learning some new technologies, it can essentially augmentate your progress. For complete beginners, when, for example, you're just starting to learn programming, software development, you need some knowledge to start really writing some programs. But here you may study and write it simultaneously. This is great, I think. This is very immersive. So this is the first point. And the second one is for experienced developers. Anyway, there are a lot of AI-powered tools and assistants to help. For example, I will note GitHub Copilot, of course, on the next slide. I read some statistics from GitHub, and they say that around 27, I guess, % of the code is the code generated by Copilot that is now attributed to GitHub. So this tool is actively used, and it does not replace the developer. It just make him more effective. The speed of developing some routine pieces of code, snippets, maybe can be significantly increased. And finally, the last one is for testing, for generating unit tests, end-to-end tests. This is another area where AI can help. It will contain generating unit tests itself by, for example, some sort of description. It can, what is more maybe interesting, it can be used for creating end-to-end tests. For example, if you want to compare the visual output in web development, yeah, you can just provide not only text description but an image how it should look, and make those models to compare if there are no visual changes that you don't want to have. So this is another promising area, but I will stay with the basic one. So GitHub Copilot is I don't know, maybe I hope some of you have already tried it. Of course, it's a paid service for commercial use at least, but it can greatly help you to improve your speed of developing some parts of the code. Again, it will not write you a complete software in the industry, in real world, because well, software engineers and developers are not only the man who just or the person who writes code. They are thinking, they are planning, they are creating architectures, and are much more than writing code. So it's far from substituting a developer, but it can greatly help to automate routine processes. And well, the main idea of GitHub, you provide the context and it provides you suggestions of the code, and you can improve it. This cycle can be made multiple times. GitHub obviously was trained on all those huge amount of code available on GitHub, and so it's really good, and it supports a lot of languages, and I encourage you to try it. If you want some open source analogies, I would advise you to have a look at StarCoder that was trained on the stack. Code data, it's completely open source, and no fees and so on. This is great. And if you want something even more general, probably the most promising and well-known open source LLM is Falcon LLM with 40 billion parameters. Of course, you will not start it on your personal PCs. It will require much more memory, but memory of your GPUs. But there are many different LLMs, smaller ones. Some even may run on the CPU. So if you want, again, I encourage you to make a small search and you'll find a model that you can start on your PC or notebook and give it a try. Finally, market believes in AI. It made stock indexes rise at the end of last year. For example, NVIDIA, the main producer of chipsets, GPUs, has almost doubled its values after those models appeared. You can see the prediction until the 2030s that the investments will greatly rise in deep learning, and this includes generative AI and LLMs as well. But I want to point your attention that if you look back at the history of artificial intelligence, well, you can see those waves when big expectations and investments was followed by even larger falls. We can say what's happening now, for sure, at least. Is it a jump on a new quality level, or is it just a new wave? Well, wave, we'll see. That's what I can say. Because indeed, modern AI have a lot of risks. Those risks not only is about losing jobs for people, but as we saw earlier, it will affect the jobs, definitely. Just imagine maybe copywriters, designers, and so on. They should definitely change to meet new requirements of generative AI and so on. But there are another problems of privacy, of regulating the usage of AI software. Greater models have more environmental impact. Generative content definitely allows the huge spread of fake content, propaganda, and so on. So a lot of questions, risks that humankind should deal with. And just to finish this small lecture, I would like you to see this small summary of 22 probably most well-known AI authorities in EEE spectrum, and they were asked the question, what's about the future of AI? Among this 22 persons, 8 experts believe that LLM can lead to AGI. Remember, AGI is artificial general intelligence. It means intelligent agents. So a general purpose applications, robots, doesn't matter, let's name it agents that are very close to human possibilities. So 8 of them believe in this, but 4 believes that AGI could lead to doomsday. So as you can see, quite a lot of prominent people in the industry warns about the AI. We'll see, but now European Union authorities are preparing strict regulations for AI for AI industries, let's say, and the usage of such large models and so on. There are talks about if we should prohibit and restrict training even larger language models, but well, those are actual and open questions. And that's it for me. I'm now waiting for your questions. You may find more information on our YouTube channel or contact me there directly. So questions, please.
Come on, guys, don't be so shy. Do you have some questions?
No.
Okay. Oh, it's some question in the chat.
What's the best way to become June machine learning engineer? Okay, I think that the best way, first, if you would ask me about what materials you should learn, I will say that you should go for the most recent one, because this field is developing so rapidly that there are no big books with fundamental knowledge. Of course there are, but it is more about classical machine learning. If you want to make a quick and deep dive, I encourage you to maybe take some courses on let it be Coursera, Udemy. Deep learning AI is very great. So you should get familiar with, of course, the basics of machine learning, deep learning, then understand what the language models and other generative models are. Then, of course, the dominant language is Python, so you should be good at Python, and you should improve yourself in this direction. And of course, you should start now, because all those things about LLMs, lang chains that I was talking about today, it has just appeared. It's this year and maybe the end of the previous one. So it's brand new, and you can jump right in it and become a machine learning engineer. I don't know about available vacations, but I'm just talking about well, the requirements, technical requirements, hard skills. Any other questions?
One question would be, I want to know where we can read about new technologies that you speak about LLM and this, where we can read about it.
Again, I can't advise some single source of information. Of course, and I also understand that it may be hard to find a really good source, because there are a lot of materials and the quality is different. That's obviously truth. I can advise you to have a look to start with the materials courses, maybe some of well-known person, like in the industry. It may be, for example, Andrew Ng is making a lot of educational content on deep learning.
Can you write it in chat?
Sure. So you may take a look at deep learning AI, AI. Visit this website and you'll find more information. There are a lot of courses by them on Coursera, Udemy, as I said. So start with them, but you should understand that this will give you some basic foundational information, and
See,
then
I have basics. I want to know about you, about this year.
yes, I understand, but they already have a lot of courses on LLM, prompt engineering, using of these models for real time, for real applications, like I showed, using LangChain and other frameworks. So it's already there.
Mhm, mhm. Thank you. Thank you.
Yes.
Mhm.
Other questions?
Okay, I think it's no question. Thank you so much for this interesting information, for participating in our Olympiad.
Thank you.
Thank you. Thank you.
See you. Wish you good luck for all the participants.